Hi, I'm Carmela. Are you having difficulties in proving identities? Here are some tips that could help you fix that problem. First, you must familiarize yourself with the different fundamental trigonometric identities. Before we can able to prove identities, you must know how to simplify trigonometric expression. Like for example, we have the expression sin x minus sin x cosine squared x. To be able to simplify this expression, we must get the common factor of this expression. And their common factor is sin x. And to get the other factor, we have to divide each term by sin x. So sin x divided by sin x is 1 minus sin x cosine squared x divided by sin x is cosine squared x. You will notice the presence of one of the Pythagorean identities, which is 1 minus cosine squared x, which is equal to sin squared x. So that we can replace this by sin squared x. So we copy sin x, then we replace this by sin squared x. Then taking the product of sin x and sin squared x, we get sin cube x. Therefore, the simplified form of sin x minus sin x cosine squared x is sin cube x. Let us have another example. Sin theta over 1 plus cosine theta plus cosine theta over sin theta. To simplify this expression, we simply perform the indicated operation. In this case, the operation involved is addition. You will notice that we are adding two terms that are in fraction form, and their denominator are not the same. Isn't that if we are adding the similar fraction, we have to get their least common denominator or LCD. And their LCD is sin theta times 1 plus cosine theta. Then sin theta times 1 plus cosine theta divided by 1 plus cosine theta is equal to sin theta times sin theta is equal to sin squared theta plus sin theta times 1 plus cosine theta divided by sin theta is 1 plus cosine theta times cosine theta is equal to cosine theta times 1 plus cosine theta. By distributive property, we can simply multiply cosine theta by the each term. So we write sin squared theta plus cosine theta times 1 is cosine theta. Cosine theta times cosine theta is equal to cosine squared theta. Then simply copy the denominator, which is sin theta times 1 plus cosine theta. Isn't that addition is commutative? Therefore, we can rearrange the numerator into sin squared theta plus cosine squared theta plus cosine theta. Then copy the denominator. We can group sin squared theta we can replace this by 1. So 1 plus copy cosine theta and the denominator, which is sine theta times 1 plus cosine theta. We can cancel 1 plus cosine theta. What remains is 1 over sine theta. By reciprocal identities, isn't that 1 over sine theta is equal to cosecant theta? Therefore, the simplified form of this expression is cosecant theta. Since we already know how to simplify expressions, we are now ready to prove trigonometric identities. I want to introduce to you one of my friends who can help us.
Hi, I'm Lorden. I've heard from my friend Carmela that you are having difficulties in proving identities. I am glad to be a great help to you. Let's start with the simplest one. For example, we have cosine theta, cosecant theta is equal to cotangent theta. In this case, we will choose the left member or the left side than the other side because it appears to be the most complicated one. So here's now the proof. We copy cosine theta, cosecant theta is equal to, in order to prove that this is really equal to cotangent theta, we have to transform this in terms of cotangent theta. As you can see, we already have the presence of cosine theta. So we copy cosine theta. For cosecant theta, we can replace it by 1 over sine theta. One of the reciprocal identities. By taking now the product, we get cosine theta over sine theta. Do you remember one of the ratio identities? That cosine theta over sine theta is equal to cotangent theta. So, we can replace cosine theta over sine theta by cotangent theta. Isn't it? We are trying to get cotangent theta. Therefore, cosine theta, cosecant theta is really equal to cotangent theta. Let us have another example. 2 secant squared x is equal to 1 over 1 minus sine x plus 1 over 1 plus sine x. This time, the right member appears to be the complicated. Here's the proof. Copy the right member, 1 over 1 minus sine x plus 1 over 1 plus sine x. We will show that the right member is really equal to 2 secant squared x. Since the functions involved are already in form of sine, we simply perform the indicated operation, which is addition. In adding the similar functions, we get the LCD, or the least common denominator. And the LCD is 1 minus sine x and 1 plus sine x. Then, the LCD divided by 1 minus sine x is equal to 1 plus sine x times 1 is 1 plus sine x plus the LCD divided by 1 plus sine x is equal to 1 minus sine x times 1. We get 1 minus sine x. We now remove the grouping symbol. We get 1 plus sine x plus 1 minus sine x. Then simply copy the denominator. 1 minus sine x times 1 plus sine x. Then combine like terms. 1 plus 1 is equal to 2. Then simply cancel positive sine x and negative sine x. What remains is 2 all over the denominator, which is 1 minus sine x times 1 plus sine x. Then, we copy 2 over the product of these 2, which is 1 minus sine squared x. With the use of Pythagorean identities, we can replace 1 minus sine squared x by cosine squared x. So we have 2 over cosine squared x. We can express this as the product of 2 times 1 over cosine squared x. Then, with the use of reciprocal identities, we can replace 1 over cosine squared x by secant squared x. Then we get 2 secant squared x. Isn't it that we are trying to get 2 secant squared x? Therefore, we have proved that 2 secant squared x is really equal to 1 over 1 minus sine x plus 1 over 1 plus sine x. Let us have this example. Cosine squared theta over 1 plus 2 sine theta plus sine squared theta is equal to secant theta minus tangent theta all over secant theta plus tangent theta. This time, it seems that both sides looks complicated, so we manipulate them simultaneously. Here's the proof. Copy the left side, cosine squared theta over 1 plus 2 sine theta plus sine squared theta. Since we haven't proved that the left member is really equal to the right member, we will use this symbol. Then, copy the right member. Secant theta minus tangent theta all over secant theta plus tangent theta. We will try to simplify both sides simultaneously until both sides appear to be equal. Let's start with the left side. To simplify this, we will notice that the denominator is a perfect square trinomial. To check whether it is really a perfect square trinomial, let us consider these 3 characteristics. First, the first and the last terms are both perfect square. Second, the first and the last terms are both positive. And lastly, the middle term is twice the product of the square roots of the first and the last terms. Since we have shown that the denominator possesses all the characteristics, then the denominator is really a perfect square trinomial. Therefore, we can express it as a square of binomial. So, copy the numerator cosine squared theta over 1 plus sine squared theta, sine theta squared. Let us simplify now the right side. The functions involved are secant and tangent. We can replace secant theta by 1 over cosine theta using reciprocal identities. And minus, we can replace tangent theta by tangent theta cosine over cosine theta using the ratio identities. All over by 1 over cosine theta plus we replace tangent theta by sine theta over cosine theta. Since both sides are not yet equal, we will put question mark above the equal sign to indicate we haven't proved the identity yet. We can still simplify the left side. Using the Pythagorean identities, we can replace cosine squared theta by 1 minus sine squared theta and copy the denominator. Then, on the right side, we perform the indicated operation. For the numerator, we simply subtract the numerator of each term, 1 minus sine theta over, copy the denominator, all over. For the denominator, we simply add the numerator of each term, 1 plus sine theta over cosine theta. Since both sides are not yet equal, we will put question mark above the equal sign. Then we can express in the left side, we can express the numerator as the sum and difference of two terms. So, 1 plus sine theta times 1 minus sine theta. Then, copy the denominator. On the right side, for complex fractions, we can turn it into the product of the numerator and the reciprocal of the denominator. So, copy 1 minus sine theta over cosine theta times the reciprocal of the denominator, which is cosine theta over 1 plus sine theta. We will still use the symbol equal sign with question mark above it. On the left side, we can cancel 1 plus sine theta. What remains is 1 minus sine theta over 1 plus sine theta. On the right side, we can cancel cosine theta. Then, we can take their product. The result is 1 minus sine theta over 1 plus sine theta. Since both sides are equal, therefore, we have already shown that cosine squared theta plus over 1 plus 2 sine theta plus sine squared theta is really equal to secant theta minus tangent theta all over secant theta plus tangent theta.
Thank you, Lorden, for your big help.
You're always welcome, Carmela. It's my pleasure to help a good friend like you.
And for our viewers, I hope you've learned something from us. Until next time.
Bye.
Bye.
I'm at a payphone trying to call home. All of my change I spent on you. Where have the times gone, baby? It's all wrong. Where are the plans we made for two? Yeah, I know it's hard to remember the people we used to be. It's even harder to picture that you're not here next to me. You say it's too late to make it, but is it too late to try? And in our time that you wasted, all of our bridges burned down. I've wasted my nights, you turned out the lights. Now I'm paralyzed, still stuck in that time when we called it love. But even the sun sets in paradise. I'm at a payphone trying to call home all of my change I spent on you. Where have the times gone, baby? It's all wrong. Where have the plans we made for two? If happy ever after did exist.
Buddy, are you having difficulties improving identities? Here are some tips that could help you fix the problem. First, you must familiarize.
Hi everybody! Ulit. Hi everybody! Are you having difficulties in proving identities? Here are some tips that you could help you fix that problem. First, you must familiarize yourself with different... To be able to simplify this expression, we must get the common factor of this expression. And their common factor is... Equals. Then, since we already know how to simplify expressions, we are now ready to prove trigonometric identities. I want to introduce to you one of my friends who can help us.
Hi.